In this video, I am going to show you how do we test the difference between two means in the dependent samples. Okay, what do you mean by dependent sample? We will first discuss about that. So the dependent samples is something that usually if you collect the data from the same sample at two different times, okay, so basically the subjects are the same. For example, if you want to test the effectiveness of certain drug that is used for the cholesterol, what you do is you collect the blood cholesterol level of a sample of certain people before they use the drug, and then after they use the drug, and then measure the difference there. Okay, so that can be the best example there. So samples are considered to be dependent samples when the subjects are paired or matched in some way. Dependent samples are sometimes called matched pair samples. For example, if certain data are collected from a sample at two different times, the samples are dependent because they were collected from the same samples or same subjects. A medical specialist may want to see whether a new counseling program will help subjects lose weight. Therefore, the pre-weights and of the subjects will be compared with the post-weights. So what are the assumptions? Assumptions are both samples must be random sample, and the samples must be dependent of each other, and the paired sample t-test does not have normality of the population or the equality of the variance of two sample t-test. It assumes that the difference come from the normally distributed population of differences. If a normal distribution of difference is doubted, non-parametric test should be used. So this is very important thing. Okay, so what it says is, in the two sample t-test, in the previous two sample t-test, both of the sample must be taken from the normally distributed population. Okay, but here you don't have to have that. What you need to have here is the difference of the samples, because you will see the value of the sample before and the value of the sample after, or you say value of the samples or the sample data at time 1 and sample data at time 2. So you find out the difference of those values, and then that difference must be come from the normally distributed differences. That's what it is saying. That's what this number 3 assumption is saying. Okay, so the testing hypothesis in this case is similar to the one sample t-test. That is important thing. Okay, so this is not like two sample t-test. It is the one sample t-test for the difference. You do the one sample t-test for the difference. Okay, if you are testing for the paired sample test, it is same as the one sample t-test for the differences of those sample values. Okay, that's what you do. So what are the steps? The number 1 steps is, we don't write, I mean you can write mu1 minus mu2 equals 0, but usually what we write there is we write mu d. Mu d is difference between the mean. Okay, so h0 will be mu d equals to 0, and h1 is mu d is greater than 0 or less than 0 or not equals to 0, depending on right tail, left tail, or two-tailed test. Okay, so to find out the test statistic, what you need to do is you need to find the sample mean of the difference. Find out the mean of the difference. What you do is d bar equals to summation d over n. What is d? D is the difference between the values, sample values. And then find out the SD. How do I find out the SD? SD is the standard deviation of the difference. So that will be n times summation d square minus summation d square over n times n minus 1. Okay, where what is d? Where d equals to x1 minus x2. That is the first data will be subtracted from the first data of the sample 2. Second data of the sample 1 subtracts second data of the sample 2, and so on. Okay, all right, this is how we find out that. So x1, x2, this will be the difference, and then this is d square, so the square of the difference. Okay, so then what is the formula for the t-test? It is just the difference over the SD over n. This is the standard error, right? So what is the test value finally? It will be d bar minus mu d, the mean of the difference, divided by SD over root under n. This is the formula you will be using. Okay, for the test value. And then the critical value method is just use alpha and the tail of the test, left tail, right tail, and find the critical value. It is QT. And the left area, comma, DF, where what is the degrees of freedom is n minus 1. N is counted as the pair. Okay, so how many pairs are there? Like how many, you can see that how many, what is the sample size in one first sample or in the second sample, because since it is the pair sample, you will have the same numbers of data in the first and second. So you can see that n is the number of data in the difference. Okay, you can think that way too. And the degrees of freedom will be n minus 1. Okay, for the p-value method, exactly the same way. For the right tail test, you do 1 minus pt. For the left tail test, you do pt and then tdf. For the two tail test, you do 2 times pt if it is negative, if the t value is negative, test value is negative, and then this if it is positive, and then decision is exactly the same. So let us do, so it is easier if you do again, you can do by hand, or you can do by using the R. I prefer by using R. Okay, so you can do using R. It is very easy. So this is before and this is after data, right? What you do next is just type the data in the R code, type before data and after data. So that is before data, this is the after data, and then do t-test, t.test before after. Mu equals to 0 means that mu d is the mu here, and paired is true. This is important thing. Alternative is two-sided in this case, and confidence level is, oh, it should be 0.90, not 95. Why is that? Because there is alpha is 0.10. That's why confidence level is 0.90, not 95. Okay, guys. Now let me show you how do I do this using using R. Okay, this is on slide number 26. Okay, look at this, slide number 26. So null and alternative hypothesis is mu1 minus mu2 equals 0. That is also, you can write or mu d equals to 0, right? Or mu underscore d equals to 0, right? And then versus mu d not equals to 0, or you can write or, so mu d not equals to 0. You can think that way. You see that? Now that's the two-tailed test. Before data is this, after that. Let me first read what is that data about. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected subjects were pre-tested, and then they took the mineral supplement for a 6-week period. The results are shown in the table. That's the table. Cholesterol level is measured in milligrams per deciliter. Can it be concluded that the cholesterol level has been changed? So it is not like increased or decreased, it says changed. Okay, assume that the variable is approximately normally distributed. Okay, so this is the two-tailed test. I copied that before data here, after data here. You don't need that subject 1, 2. Okay, so and the t.test before comma after comma mu equals to 0, because that mu d equals to 0 is there, and paired equals to true, because this is the paired test. They are taken from the same subjects. This is from the same person. These two are also from next person. These two are from the next person as well. So this is what it is doing here. And alternative is two-sided. Confidence level is 0.90. That's what you will need. 0.90. Not 0.95, because alpha is given as 0.10. Okay. So let me run this, and then I got the, look at this p-value. That's what we look. So the p-value here is 0.1743. Then what do you write? Since p is greater than alpha, we do not reject H0. Hence, there are not enough evidence to conclude that the cholesterol level has been changed. So we cannot say that that mineral has any significant role in changing the cholesterol level of a person. You can conclude that. Okay. So what is the another way of testing the hypothesis is using the confidence interval. Look at this confidence interval. You see that? This is the confidence interval, 90% confidence interval. Does it include 0? Yes. It includes the value of the null hypothesis here. Okay. It includes 0, meaning that we do not reject the null hypothesis. If the confidence interval include the value from the null hypothesis, then we do not reject it. If it does not include, then we reject it. Okay. So what is this? Mean of the difference is basically what they did is they found this minus this, this minus this, this minus this. That will be mu d, right? That is the that is the d. So D is the difference of all these numbers, and they found out the average or the mean of that difference. That is what is 16.5. That's what they noted here. Okay, because if you have to use the formula, then you will have to find out before minus after. That will be D, and then find out summation D over N will be the D var. Similarly, find out SD, and then you plug there, and then to find out the T value, that is the test value, using that, and then use those steps. Okay, guys, so you can do that way. So look at this. What does it do? It says, what is the formula for the confidence interval? Is the 1 minus alpha confidence interval is this, D bar minus T alpha half. This is the standard error, right? SD over root N is less than mu D is less than D bar plus T alpha half SD over root N. Let us look at this this problem. Okay, so what I'm going to do here is I want to do by R, but let me read this question first. There is a common belief that college students typically gain 15 pound weight during their freshman year, called freshman 15. A random sample of 10 students have their weight recorded in August and May of their freshman year is given below. Write H0 and H1. You need to write the null and alternative hypothesis. Okay, so what would you write? He says that, so 15 pounds, so the common belief that the college students typically gain 15 pounds weight during their freshman year. A random sample of this, write H0 and H1, find the confidence interval for the mean difference between their weights. Do you think the belief is true? So they say that they gain 15 pound versus we say not gain 15 pound, right? So you want to test like that. All right, guys. And then, but what you want to do is you want to test the hypothesis by 95% confidence interval. Okay, so this is a person's weight on the August, and then the May, the coming May, okay, of that year, and then another person 64, 74, another person 66, 73, and so on. Okay, guys. So let me see. It says a 95% confidence interval. Okay. So this is what I'm going to do here is let me see which problem is that. Oh, this should not be mu1 minus mu2 equals to 9. So what I want to write here is actually this is, I mean, this is mu d, right? Mu d, mu underscore d equals to what? Not 9, it is 6.8, right? So 6.8 versus it is what you do, it is not equals to, right? Not equals to, or you can say less than or not equals to 6.8. Okay, so what they said is, because all these data are in the kilograms, so I'm just using that kilogram. So what does it say is null hypothesis is the average weight gain is 6.8 kilogram. The alternative hypothesis is not 6.8 kilogram. Okay, it doesn't say less than or greater than. That's why I'm taking two-tailed test. Okay, now this is the data in the August and this is the data in the May. It looks like all of them have gained some weight there. Okay, so how do I do the, I mean, you can actually find out the 95% confidence interval using this formula directly, or if you do the t-test will give you the 95% confidence interval directly. Okay, so so you can do from the t-test, or you can do like what we did before, you remember that doing this C and then doing that using that formula. You can do either way. Okay, I like here, what I did here is I tried using the t-test. Again, it will give you the same confidence interval, and we can decide from the confidence interval. Okay, so what we can say here is, since let me find out what we get first. So this is the weight, I'm running line 155, and this is the weight in the May, and then what I'm doing is I'm doing t-test, and see paired is true and alternative is two-sided. What is the confidence interval here? Confidence interval is 95%, so we are good. So confidence level is 95%. Okay, so what do we get? Does it include 0 or no? No, right? Because it includes the number between negative 7.8 through negative 2.9. So there is no 0 in the middle of those. So what we do, since I'm using 95% confidence interval, okay, since the confidence interval, so confidence interval does not include 0, we reject a 0. Hence there are enough evidence not to believe that the freshman student's average weight gain is 6.8 kilograms. That's what we get. Okay, guys. So this is how we do the paired sample. But be careful when you are asked to do the two sample test for the mean. So if the population variance are given, then we do the z-test. But if the population variance are not given, we use t-test. But do we use the paired two-test or unpaired two-test? Do you use the dependent sample or independent sample? You should be careful when you pick that. So usually after you read the question, then you can tell whether it is dependent or independent, right? Most of the times, if the data are collected from the same samples before and after, or at two different times, okay, so if the data are collected from the same samples at two different times, then that type of samples are the paired samples. Okay, so in that case we will be using paired sample t. So this is what you this is how you do the paired sample test. The next thing we will do is the power of the test. So to find out the power of the t-test, okay, to find out the power of the t-test, we use R. So the concept of the finding the power is same. It is like the type 1 error, type 2 error, and then power is 1 minus the type 2 error, that is 1 minus beta, right? So R has a very nice feature to find out the power. What we do here is, see, we use R to evaluate power of the test or the required sample size. You can find out the sample size also, okay, using that. So but whatever you want to find, you should keep that null. Okay, see, power dot t dot test n is equals to minimum of n1 n2, so minimum of those n1 and n2. SD equals to SP, pool standard deviation. Okay, so delta is equals to the difference of those two delta values. Okay, the two means. Delta is the difference between the two means, two given means. Okay, and then power is equals to null because you were trying to find out the power. So significant levels, see, instead of confidence level, I am using significance level. That's the same thing, right? So confidence level you will be using 1 minus alpha. Significance level you are using just alpha. Type is two sample and alternative is two-sided, where SP is given like that. You see that is the pool standard deviation. And if you need to find sample size n, then you will be using SP equals to, because at that time you will not have n1 and n2. Okay, at that time you will be using SP equals to under the root S1 square plus S2 square over 2. So for the paired sample test, this is for the independent sample test. For the paired sample test, power dot t test n equals to n, because you will have the same sample size on both. Delta equals to the difference between the means again, and SD is equals to the standard deviation. Okay, SD is the standard deviation of the difference. You find out the difference, and SD is the standard deviation of the difference. And the significance level is 0.05, again the same thing. Power is null, type is paired. You should not forget that. So type is paired and the alternative is two-sided. So we'll see examples on that. Okay, guys. All right, let us see that power of two sample t-test here. So let us look at this example. It says that I'm giving you this example from that chocolate and non-chocolate carbohydrate data. Okay, so in order to the power of the two sample test, the R built in power dot t dot test is easier to use, where delta is the difference between the true difference. Okay, true difference and hypothesized difference of means. Okay, because what is the null hypothesis? Mu1 minus mu2 equals 0. 0 is the hypothesized difference, and if the true difference is different from 0, that will be that different of those two numbers, those two values will be the delta. Okay, also the standard deviation, for the standard deviation we use pool standard deviation, and if the variance is known, we use that variance. That's what it says. In the above carbohydrate example, in chocolate and non-chocolate data, find the power of the test if the true difference between the let's say if the difference between the true and hypothesized different, right? So between the true and hypothesized difference is 6. Okay, so here the data one is that data I just copied and pasted, and n1 is length of data 1. This is the sample size of the first sample. N2 is the sample size of the second sample, 13 and 11, right? And S1 and S2 are the standard deviation of the first and second sample. SP is the pool standard deviation. I use exactly the same formula. Now power of the t-test, what did I do? N is minimum of N1, N2. SD is equals to SP, pool standard deviation. Delta is 6, which is the difference between the true difference and the hypothesized difference, which is given as 6. Okay, and power is null because you want to find out the power, so I kept this null. Significance level, see, I use significance level here. Why did I do that? Previously we had confidence level, here we are using significance level, so it's the same thing, right? So confidence level was 1 minus alpha, significance level is basically alpha, and type is 2 sample, alternative is 2 sided. Okay, so let's look at that. Oh, we got that already. So what did you get? You got so n is the minimum of that, right? So what is the power? It's 86% power. Okay, so power is the 86%. So do not reject the null hypothesis when it is true, right? So that is the power. Do not reject the null hypothesis when it is true, because type 2 error is fail to reject the null hypothesis when it is false, right? So so that's complement of that is basically reject the null hypothesis when it is false, right? So that is the 0.8635, that is 86.35%. Okay, so if you want to know the sample size, for example, here suppose you want to know the sample size, to evaluate the sample size with given power, if power is given, for example, I want to keep the power of my test is 90%, what should be the sample size, what should be the minimum sample size? If you want to do that, I have given one example here. Okay, for n you should do null, and then for power you should do 90% if you want to keep your power of the test 90%. Okay, so and then in that case we use SP, pool standard deviation will be square root of S1 square plus S2 square over 2. Okay, that's what you should do. So look at this example here. I am giving you one example. A clinical dietitian wants to compare two different diets, A and B, for diabetic patients. She hypothesized that diet A will be better than diet B in terms of lower blood glucose. She plans to get a random sample of diabetic patients and randomly assign them to one of the two diets. At the end of the experiment, which lasts 6 weeks, a fasting blood glucose test will be conducted on each patient. She also expressed that the average difference in blood glucose measures between the two groups will be about 10 milligram per deciliter, I think. So this is the average difference, okay, in the blood glucose measure between the two group will be that. And furthermore, she also assumed that the standard deviation, okay, standard deviation of the blood glucose distribution for diet A to be 15 and the standard deviation for the diet B is 17. The standard deviation is also given, so you will have to find out that pool standard deviation. The dietitian wants to know the number of subjects needed in each group assuming equal sized group. See, what is this? That what we have here is, I saw a number 10 here. The average difference in the blood glucose measures between the two groups, that is basically mu1 minus mu2 is 10, right? So that is the true value. Okay, we will be testing mu1 minus mu2 equals to 0 versus not equals to 0, right? But the true difference is 10. The difference between the true value of the population average is 10, but we will be testing for 0. What is the difference between the differences? Is 10 actually. That's why we take delta equals 10. Since you were asked to find out the n, so we keep n equals to null. S1 and S2 is used to find out the pool standard deviation. Since the pool standard deviation has S1 square over N1 and N2, but we want to find out what should be that N1 and N2. Okay, so see, so the dietitian wants to know the number of subjects needed in each group, assuming equal sized group. So she wants to select the sample, but she doesn't know how to what should be the minimum sample size. Okay, so what we do is she wants to let's see what power she wants to. Does she say that she wants to keep the power of the test 80%? It doesn't say that, but what we assume is that power is 80%. That is the minimum power we want to have in our test. Okay, so n is equals power dot test, n is equals to null, delta is 10, sd is sp, that sp, signal level is 0.05, and power is 0.8. so we assume type is 2 sample, alternative is 2-sided, streak is true, so no worries about that. So what we do is if you run that, I got n is 4.22, that is 5, so you need to have n5. Okay, so if you want to have the power of the test is 90%, 0.9, what would that be? That is 5.2. that means you need to have 6. The sample size must be 6 in that case. So this is how you find out the power. So how about power of the t-test if the pair is the sample is paired? Exactly the same idea. Okay, if you want to find the sample size or the power, you do the same thing, but here type will be, instead of 2 sample you will be doing paired. Okay, instead of 2 sample you will be doing paired. Okay, let's see this example. What does it say? Okay, so example, a company markets an 8-week-long weight loss program and claims that at the end of the program, on average, a participant will have lost 5 pounds. Okay. On the other hand, you have studied the program and you believe that their program is scientifically unsound and should not work at all. With some limited funding at hand, you want to test the hypothesis that the weight loss program does not help people lose weight. Your plan is to get a random sample of people and put them on the program. You will measure their weight at the beginning of the program and then measure their weight again at the end of the program. Based on some previous research, you believe that the standard deviation of the weight difference over 8 weeks will be 5 pounds. You now want to know how many people you should enroll in the program to test your hypothesis. Look at this. It says a company markets and weight. See, before and after, there must be the true difference must be 5 pounds. Okay, that is the delta value. Okay, standard deviation is also given as 5 pounds. Standard deviation is given as the 5 pounds for the difference. Okay, so now you do the power dot t test to find out the power. So to find out n, you keep this null and then enter all those values here. Power we want to keep 80% at least, that's why, and then type is paired. This is important thing. And if you run this, what do you get is you need to have at least 10 people involved in that to keep the power 80%. Okay, so if you increase the power, let's say 90%, how many people do you need? You need 13 people. You always round it up. Okay guys, so this is how we find out the power of the test as well.